This is John Singeri, the Chief Marketing Officer here at Active Endpoints. And I'm joined by Dr. Michael Rowley, who is our Chief Technology Officer. The topic today will be boundary events in BPMN 2.0. Before we get started, though, I want to just cover a couple of things with you. At least in terms of background, the reason why we're doing these BPMN Tuesdays is hopefully for something new for you to learn by an industry expert, like something like Michael. And we pick relevant technical topics related to BPM, SOA, industry standards, and any other important topics around BPM. So we appreciate you listening today, and there'll be more to come. In terms of just mechanics, oops, sorry about that. Just in terms of mechanics on GoToWebinar, as you'll see on the screen, you can maximize the screen by just hitting that button to the right. And after Michael initially speaks, we'll have a Q&A interaction. At least it's our view that this could be one of the most valuable pieces to the presentation because it really gives you an opportunity to ask Michael in terms of anything else that is of particular interest to you. Okay, what I'd like to do is introduce Michael, and again, regarding BPMN 2.0 boundary events.
Thanks, John. So BPMN has had this concept of boundary events as one of the kinds of events, one of the ways of using events. So I'm going to be discussing, first I'll discuss a little bit about events in general, just to review that briefly, and then I'll go into what boundary events are, how they're different from other uses of events, and when they're best used, show in the ActiveVOS tool how you create them and use them, and then also describe how they're mapped into BPL. So first, to review BPMN events themselves, there's a few different ways of looking at an event to make sense of it. The boundary of the event, the lines around the circle, the contents of the circle, its color, and then the shape. So let's start with the actual circle itself. An event can be a start, intermediate, or end event, and you can tell that by looking at the circle. If it's a single thin line, it means start. If it's double line, it means intermediate, which means it's the middle of the path. Something else is already going on. And if it's end, it means this is the end of the path. Nothing should come after it. The end being a thick line. Then there's dashed, and there's two forms of dashed. The dashed means that this event is not going to interrupt something else that is happening. Double dashed means something else is going on, and I'm not going to interrupt. So you'll see more of that in a minute. That's the border of the event icon. The next thing is the color of the icon in the middle. Events are about either noting or causing something to happen, or waiting for something to happen. Those are pretty important differences. The black icons are for signaling events or creating a new event. The white icons are for waiting for an event to happen. We're not going to be talking much about the black icons because they can't be used as boundary events. It's the white ones, the ones that wait for something to happen, that can be used as a boundary event. So on the bottom of this, you can see a really simple example, probably the simplest example of a process, which is to start the process by receiving a request, do some piece of work to figure out how to respond, and then an end event that is also a message event to send the answer. So you can see the black as well as the fact that it's an end event, as well as the white and the fact that it's a start event here. So now there's these different places where events can occur. There's the ones that are in line, beginning a sequence, in the middle of a sequence, or at the end of a sequence flow. So that's this on the left. On the right, there's a concept of an event subprocess. You've got the main process going on, and then you've got a dashed border around an entire area, very much like a subprocess. What makes it an event subprocess is the fact that it's dashed instead of a solid border, and the meaning of that is anytime during the main process, it's ready to receive this event and do the work that's in this event subprocess. So that's the second form. The third form is that you can put an event onto the boundary of either a simple activity or a subprocess. And that's what we'll be talking more about today. So what are these things? They can go on activities or scopes, and they handle events that occur while that activity is in process. The work of the handling of the event is done by what we call downstream activities. And those activities are at the same level as, kind of in terms of scoping, as the activity that the boundary is on. This is in contrast to those event subprocesses where the handling of the event is encapsulated. It's embedded in some subprocess. And by the way, downstream activities just means, it's at the other end of an arrow, and then there's another arrow, and there's forks, and who knows what. But there's this directed graph that you can reach and that you can follow in response to this event having occurred. Now, the boundary events can either interrupt the activity that it's on the boundary of, or it can let it run, or be non-interrupting. And the kind of circle will determine that. So let me look. The next couple of slides are both for non-interrupting and then interrupting forms of these boundary events. First, let's look at the non-interrupting form. It's got the double circle because it's intermediate. Something else is going on, and that's what this task is, in do a task. It's dashed, so that means when the event occurs, don't stop it. So in this particular example, I'm saying do a task, wait 2 hours. After 2 hours, go here and do all the activities at the other end of this arrow. In this case, send email, probably to somebody saying, hey, wake up. You haven't finished yet. So the event data for that event can go into a new variable. In the case of a timer, there's not much data to actually put there, but there are other things like message events. You can wait for a message event to occur, and the message itself has to be stored somewhere. It gets stored into a new variable that's associated with that boundary event. And then all of the downstream activities have access to that event variable, in addition to the regular variables that are associated with the process or scope that it's in. So what happens is, conceptually, all of the downstream activities are in the scope of the activity that it's on the boundary of. And in order to do this, all of these activities have to be disconnected from the rest of the graph. And there's another reason they have to be disconnected from the rest of the process graph, and that is that because it's non-interrupting, you can get many of these things occurring, and potentially even many happening at the same time. So in the case of a timer event, it's not going to happen, but in the case of a message event, you could imagine something that's like asking for status, and you could have many requests for status coming in pretty much on top of one another, and in such a way that they're all being responded to simultaneously. So each of these disconnected graphs of activities that is responding, each will occur together simultaneously in response to the request. So example uses of non-interrupting boundary events, things like a message from the client saying, what's the status of my process? And you'd like to respond to that anytime during a particular range. Maybe a message that says, I want to modify the order that I placed. There may be places in your process of processing the order that you can accept modifications to the order, and there's not a problem. And another one, it might be this timer event where you send a reminder to a worker or their boss if you want to escalate. So that's non-interrupting. Next is interrupting boundary events. So these stop the activity or scope that they're on the boundary of. The event data goes into a variable of the enclosing scope. There has to be a variable somewhere around in whatever the process is or scope is that you're using, and the data will be given to that, such as a message or false data. And then the downstream flow or those activities are allowed, unlike the non-interrupting ones, they're allowed to rejoin the process later or even potentially loop back to an earlier process. So this is something along the lines of, you know, if you want to update the order, maybe it needs to go back to an earlier step. So example uses, canceling an order is typical for interrupting. Timers could be used for not just escalation, but for timing out, where a timeout is something along the lines of, this is after a certain amount of time, it doesn't matter anymore, something completely different should happen. Or error events, where error events tend to be generated from inside the activity that it's on the boundary of, and then the boundary event will point into the direction of how to handle this particular error. And here's a couple of examples of connecting and non-connecting downstream activities. You can see in my dashed circle, the non-interrupting one, that's disconnected set of downstream activities. For my interrupting boundary event, you can see it's got a connected set of downstream activities, meaning it's connected to the same flow that you would do if the boundary event never occurred. So, and finally, I'll go into the specific kinds of events there are. There's message events that can be both interrupting or non-interrupting. There's alarm events that can be both. A catch event is catching a problem that's happening inside the activity that you're on the boundary of. So by its definition, it stops the activity that's going on. And so there is no non-interrupting version of the thing. A compensation event is also usable as a boundary event. It's a little bit different. It's kind of not really interrupting or non-interrupting. It's shown as an interrupting, I mean, it's got the double circles. But the semantics of it are that it only happens after that activity has completed and something else then later requests that it be compensated. Usually it's because something else in the process failed. Then it points back to some earlier activity and says, compensate those earlier things. So it's shown as interrupting, but it doesn't actually interrupt, and it has to be a disconnected subgraph in the way that non-interrupting events are. So what should I use? For inline receives, and all of these are receives. Sending it's more obvious. For inline receives, it's easy. You do it when you need to prevent continuing until I receive a specific activity. None of the other two will prevent the process from going forward. They'll just be available to be called at certain points, and then if they're not needed, it just continues without them being ever used. Inline Receive is very specific to don't go until I get it. Event subprocesses, these are the dashed border around the entire area of the handler. Those have a couple uses. One of them is, I think they're really useful when you want the event handling to be hidden. You'd like for a sub-process to exist, for that to be able to be collapsed, and with that collapsing, you also want to be able to collapse the handling of some or all of its events. That's very much a judgment call onto what things deserve to be at what level. The highest levels of the process really should be for things that you're going to be sharing with the people who want a general idea of what's going on and they don't need to know specifics. And you should have to drill down only if you're wanting to know more of the details. And so event subprocesses are good for that. They're also good because they're kind of encapsulated in the thing that they're handling an event for. It's useful when you want to get access to the variables of a scope. So a scope defines variables. If you declare a boundary event for it and go off somewhere else, that somewhere else doesn't have access to those variables. But so if you want access to the variables and you want to make it clear that you've got access to the variables, you use the event subprocess. And another thing is errors. There's no way in a boundary event to say go wherever you would have gone if the thing had completed successfully. So in other words, to essentially swallow an error. Say, I handled the error. As far as I'm concerned, the activity is done and it worked, right? You can't do that with a boundary event. So use event subprocesses to swallow errors and treat it as if it had completed successfully. So boundary events are useful for interrupting scenarios. You can't use event subprocesses for anything that will interrupt. When you want to show events at the same level, show activities at the same level as the activities that the boundary is on. And then finally, and this is kind of a special case of number 2, when you're using swim lanes, and you want to say, have this, after 2 hours, escalate to this other guy. You want to represent this other guy on a different swim lane. And you can't do that if you're using event subprocesses. So that is really useful. So before I get into mapping to people, let me show you what it looks like. And in fact, let me show you a process that uses them. So here's a process that has a couple of non-interrupting events, boundary events, on a scope. So this is the quote process that some people have seen before. And this is saying, anytime during the handling of this quote, if somebody asks for status, give them the status. If 48 hours has gone by and we're still in there generating the quote, then notify the chief who's going to investigate why this is taking so long. Now, I'm showing those two things as boundary events on a collapsed scope. If I drill in, I can see there's actually inside that scope, I've also got an event subprocess that's saying for any error, set the status to faulted and send a problem email and then swallow that and continue as if it didn't happen. There's other cases where I think it's especially useful. Some things like this, send customer email with reference number. This is saying send it, and if I can't send the email, don't worry about it. Just swallow it, and it'll keep going without it. That would be trickier to do. It's possible, but you get more lines on your screen. So those are some of the activities that use event subprocesses. If I go to Let me go to something where I don't yet have one, or where I can add a new one. Because they map so closely in Beeple to, and which I'll get into later, to handlers, event handlers, the actual gesture we use in ActiveVOS is to drag one of the handler icons for these various kinds of events onto any activity. And you can see I get a little feedback saying, yes, I can drop it onto that, and then I can link from that activity to other activities. I can make things happen, and then eventually say I'm done. And these, within the event itself, is where notice when I dragged it on, it assumed I was non-interrupting. If I just switch it with a little checkbox, I can say now it's interrupting. There's something you should notice when you see that little switch, and that's what happens to this variable. When I've got it as non-interrupting, there's no drop-down. I have to type something new here. When I check it as interrupting, it says it is a drop-down that has me select a variable that already exists in the scope. That's because it's only for the non-interrupting ones that I generate a new variable, new request. And then that new request variable is usable from downstream activities. So I can see that on this one. This is an interrupting event. Let me switch that to be non-interrupting and say new request. And then if I go to this assign and I start creating an expression, what our expression builder does is it shows you all of the variables you have access to. This is a downstream activity of that boundary event. So you can see I've got the new request among my list of variables that I have access to. That in addition to all the other variables from the scope. Let's see. It's also possible, and it will lay out in a kind of crazy way, but it's also possible to have boundary events on expanded containers in addition to collapsed containers, like you have the full scope there. So that's some of the way you actually manipulate them in the editor. Now to how these things map onto the standard execution language, which is Beeple. And for those of you who haven't come regularly, within ActiveVOS, what we do every time you're editing, you are editing Beeple. There's not a separate translation step. It is a continuously valid BPMN and valid Beeple. So, and in order to avoid any round-tripping problems. So that means that we have to make sure that as we're showing you this valid BPMN, we're also storing it in a way that's valid for Beeple. So message events become on-event handlers and scopes. Timers become on-alarm handlers. Errors become catch or catch-all handlers. And compensation become compensation handlers. If you put a boundary event on a simple activity, it creates implicitly a little scope that has nothing in it but that simple activity, and then the event handler that you've just defined. So you don't have to care about it. You don't have to create this scope that you didn't really want in the first place. We do that for you. So let me also show you some of the things that you would have to do if you didn't have boundary events for with a fairly common scenario, which is an interrupting boundary event. So what's on the left is process this loan and cancel, treat it as an interrupting boundary event, and then do some amount of work around performing the cancellation and then notifying the customer. Without this capability, the way it has to be modeled is to say, do some work, get the cancel handler, but the cancel handler is embedded within this scope. So in order to stop the scope, the only way to stop the scope is by throwing a new event, then catching that event, and then performing the cancellation, and then considering that activity to be done. So this is really, really too hard for people to really understand what you're trying to accomplish. This interrupting boundary event is much easier. So the way that we handle the mapping into people, and I'm showing this using a graphical notation that makes clear what the BPL looks like. This is kind of the classic notation that was used in earlier versions of ActiveVOS before BPMN. And you can see that what happens is you've got an event handler and then a downstream activity. For non-interrupting events, that whole graph of downstream activities is brought into an implicit scope. There's an implicit scope called process loan, or in this case explicit, but it would be implicit if it were an activity. A handler is created for it. An event handler is created for it. A new scope is within that. And then all of the activities, in this case there's only one, are brought into that for handling this non-interrupting boundary event. For interrupting boundary events, what we have to do is, again, create one of these handlers, but then within the handler have a mutually exclusive link out of it into the main body of the process. And this is the reason why for an interrupting one, you are allowed to do things like rejoin the process or loop back, because it doesn't need to move all of the downstream activities into the handler. It leaves them outside of the handler. And then one final thing, in the case of an interrupting message event, this special case, if it's a message that requires an answer, somebody is saying, cancel the application, and I want to hear that it has been canceled, and get a cancellation confirmation number. I have to have access to this data, and also BPL has to understand how to put the reply with the request. It has to understand that there's a request that comes in and a reply that goes out that corresponds to it. BPL has this concept of IMAs, or inbound message events, and all replies have to be associated with an inbound message event. You can't actually have the IMA buried inside of some sibling scope, if that makes any sense to you. In other words, this process loan is a sibling scope to notify. If this event handler is a child of it, as it naturally would be, that would normally not be something you could link up, that you could associate the event handler with the response. So we've had to do a small extension to BPL for specifically this case that says that treat this boundary event as, it's still an IMA, an inbound message event, message activity, but treat it as one that is an IMA of the enclosing scope. That allows the response to be associated with the request, and there's no problems. It's really a very trivial little modification to the BPL semantics that basically just slightly relaxes one constraint for handling event scopes. So that's it. I would say the highlight of this whole thing is not so much the BPL mapping. It's just probably most noteworthy that it's possible to map this to the standard BPL language. But I would say this is the most important thing. When do you use these various constructs? And the boundary events are usable in in many of those scenarios. John?
Thanks, Michael. I'd like to turn now to the question and answer period, and there is a chat window on the bottom right-hand side of your screen, I would expect. And this is really, as I mentioned at the beginning, where I think can be one of the most valuable pieces of this interaction. So what we'd like to do is please give us your questions, and Michael will be happy to answer them. And we'll take as many questions as we can over the next 30 minutes or so, if we get that many. But just to start off, Michael, in terms of boundary events, how often and what's the best way to do them?
How often? How often to do them?
How often?
Yeah, I would say. I would say that you'll probably find that a majority, but not a large majority, of events will be boundary events. That's a guess. You know, it really depends on the process, but I think there's a lot of cases where, especially for escalation events, where you're going to want to represent what happens in response to the escalation, using activities on the same level as the thing that you're reacting to. So that's a great use case. Also, message events. I think message events will often be things where you want to say, anytime during this, go somewhere else. So I am saying majority. Actually, I might downgrade it to about 50-50 with the event subprocesses. The event subprocesses are still very useful because of the fact that you can collapse them, ignore them at times, allow regular processing continue in the case of an event handler. So there are a lot of good uses for them, and it will be, you know, either about 50-50 or maybe a majority.
Thanks. Okay, we'd appreciate just some questions from the audience. So please type them into the chat box, and we'll take them one at a time. Okay, while we're waiting for additional questions, want to make sure that based on the slide that you have in front of you, that we do these every Tuesday, and you can see from the screen in front of you the location where you can register. We'll also be sending out invitations based on people that are already on here. Also, you can send comments and feedback to the email address or to Michael and I, which is at the bottom of the screen. You can download replays off of the website, and also there is an ActiveVOS website that you can get these, and you can see the URL in front of you also. Okay, well, we don't seem to have any questions from the audience, so I want to thank Michael for his time, and also, hold on one second, we did just get a question. Michael, on the two-phase transaction support in compensations, I guess that's the way it's written. You could comment on that?
Well, compensation is usually used in lieu of two-phase transactions. They're more of long-running transactions where atomic transactions are one where there's no visibility of something, of some set of activities doing their work until all of them are visible. With long-running transactions, you have intermediate states become visible as you encounter them, and so you'll be partway through processing an order or getting a travel reservation or whatever it is, and then something late in the processing will fail, and you'll say, oh, those things I've already done, they need to be undone. And that's where compensation comes in. Compensation is often, both in BPMN and BPL, they were made to align, get it so that you can just say generally, compensate anything that has already happened and has a compensation handler. So, and that the latter part, the and has a compensation handler, is where we get into these boundary events. So if there's a compensation boundary event on something that's already occurred, and then you later fault and need to compensate, it'll run those things to undo it, right? Undo the preparation of the order. In the case of a travel reservation, you got your plane reservation, but you failed to get a connecting reservation, and so you go back and cancel compensate the original, which means cancel the reservation that you got for the first leg or the earlier leg.
Thank you. The next question is, we need to act on generic messages generated by triggers on tables. Should we build separate on message handlers for each message type, or switch within the one handler?
I would say that if you can do it with the different types and not get overly unwieldy, I tend to say, try to be more strongly typed in your interfaces. This ultimately would come down to the interface, because with the boundary event, you can only have one boundary event per message type, right? So you're going to say, on this activity, I'm waiting for a request for status, something along those lines. That's actually an overgeneralization, because you could do things with correlation sets. But ignoring correlation sets, you basically would have only one received for each type. And if you've got this generic trigger mechanism that says receive a trigger, and it could be a wide variety of very different things that are all handled in completely different ways, it would be better to say, wait for this kind of trigger, because this is the kind of trigger I care about here, and here's how I handle it, that specific kind, and then a different one for a different kind of trigger. Each of those would be modeled in your WSDL as a different operation, maybe with the same kind of data, maybe with different kind of data, but it would be a different operation. And then it's clear. I qualified it because if there really are, dozens of these things, trying to stick a dozen handlers, boundary event handlers, on an activity just would make the thing too ugly. So you might, in that case, you might want to have it be all one.
Okay, thanks. Next question. Security checks or authorizations. How to usually embed them in event handlers?
Well, event handlers are just, as far as the execution environment is considers them, they are another kind of the inbound message activity, just like receives. And like receives, they are kicked off like a call to a service, even if that call to the service might be coming in through a messaging layer like JMS. It's still considered a call to a service. So all of the authentication and authorization associated with any service call for inbound messages is also applied, or can also be applied, to inbound events. They're not really different. An event is, as far as the environment is concerned, a service request.
Thank you. Next question. Any more questions? Okay. Well, we'd like to thank you for listening in today, and we look forward to additional topics next week. And thank you again.